Hello and welcome to another eMathInstruction Common Core Algebra 1 lesson. My name is Kirk Weiler and today we're going to be doing Unit 5, Lesson number 6 on solving equations graphically. Let me remind you that you can find a worksheet that goes with this lesson by clicking on the video's description or by visiting our website at www.emathinstruction.com. As well, don't forget on every one of our worksheets you can find the QR code that links to the video. So feel free to use a mobile device, scan that code, and it'll take you right to this video. All right, let's get into it. There's a lot of different algebraic techniques for solving equations, but one of the most powerful techniques of all, bar none, isn't algebraic, but it's graphical. Today, we're going to see how to use graphs to solve equations, and this is an amazingly important technique to learn how to use at this early stage in your algebraic career. So let's jump in and start with a pretty simple example. Exercise 1 says, consider the equation 3x minus 2 equals 10 minus x. It says, solve this equation by using standard methods and then show it is a solution by checking. Why don't you pause the video and take a couple minutes to do that right now. All right, let's go through it. It's pretty easy. I'm sure by this point in time, in this course, even coming into this course, you were probably very good at taking linear equations with variables on both sides. Apparently, I'm not very good at drawing lines, but we're just going to walk through some basics, right? Divide both sides by 4, and of course, we get x equals 3. Now we can easily check that x equals 3 is a solution by substituting it into the left side and the right side and seeing if the two are equal. Here we're going to get 9 minus 2. Here we're going to get 7. And 7 is equal to 7. Great. All right. But now what I'm going to do is I'm going to show you two different ways that you can solve this graphically. We're going to solve it by looking at a table, and we're going to also solve it by producing a graph. So, letter B says, using your calculator, fill out the table below for the two expressions. Circle the solution you found in A. So we're going to do this in a really kind of neat way. What we're going to do is we're going to treat both sides of the equation as if they were equations themselves. All right? And we're going to put them into our calculator as if we were going to graph them. All right? So right now, we're going to open up the TI-84 Plus. Here it comes. All right. We're going to go into y equals. That's simple enough. If we have any equations there, we're going to clear them out. And what we're going to do is in y1, we're going to put in the left-hand side of the equation, 3x minus 2. And in y2, we're going to put the right-hand side of the equation in, 10 minus x. It really doesn't matter which one you put in which, but it makes sense to me to do it that way. And now what we're going to do is we're going to take a look at the table instead of looking at the graph. Now I'm going to go into my table setup right now. I'm going to make my table start at 0, and I'm going to make it go by 1. So that's my table start and my delta table. Okay. And now let's go into the table by hitting second graph, and let's fill in those rows. I know here they look like columns, but we can just fill them in. All right, I'm going to put in -2, 1, 4, 7, and 10, and 10, 9, 8, 7, 6. Now, it says circle the solution you found in A. There it is, right? Now, why is that the solution? That's the solution because it's the x value that makes the output of the two expressions equal. And that's what this equation says, right? And that's what solving the equation means, is to find the input that makes the output to these two expressions equal to each other. In fact, equal to 7, right? There's the 7 in our check. So one way to solve an equation using the calculator or using graphs on the calculator, even though we don't even have a graph in front of us, is to just put the two sides of the equation in as separate equations, scan a table, and see if there are any inputs that give us equal outputs. those will be solutions to the equation. The inputs are the solutions, the x values, obviously. Now, how can we do it by just looking at a graph? All right, well, that's letter C. So let's use our calculator to do that. And I'm sorry about the fact that I have to move the calculator all over the screen, but it takes up some room. So letter C says, using your calculator, sketch the graph of the two lines y equals 3x minus 2 and y equals 10 minus x on the axes below. Use a window and then use the calculator to find the intersection point. So let's walk through this. All right, we already have our calculator open. We already have the equations in there. Let's go in and change the window to be what I told you. So window, let's put in x min is -2, x max is 6, y min is -2, y max is 11, and let's hit enter. All right, now let's graph it. Okay, wait for the two lines to come up. All right, now that we have our two lines up, we're going to use the calculator to find the intersection point. All right, in order to do this, what you use is what's known as the calculate menu. All right, find the trace button on your calculator. It's right there. And what I'm going to do is I'm going to hit second trace, go up to calculate. Now what I want is what's known as the intersection option. So I'm going to go down to intersect, hit enter. Notice the calculator now gives me some questions that prompt me. It says first curve. Now if I've only got two curves in the calculator, which is all I'm going to want when I use it to solve equations, I'm just going to hit enter. Then it asks me for my second curve. I hit enter. Then it asks me for a guess. Now this is particularly important if there's more than one intersection point. For us, there's really only one, but maybe I move my cursor kind of near where they intersect by hitting the right or left arrows. If I hit up or down, what it does is it moves the cursor between the two curves, right, from one curve to another, that is. So I'm just going to move the cursor close to the intersection. Now I'm going to hit enter, and it tells me my intersection's at 3, 7. So let me do a little sketch of that graph right there, right? I've got 10 minus x, which looks something like this. I've got 3x minus 2, which looks something like that. And we know that they intersect at 3, 7. Now the key is, and this is very, very important, is that the solution is simply x equals 3. It's not 3, 7. We're not solving a system of equations here. What we're doing is we're only finding the x coordinate. We're finding the input that makes the outputs equal. And this gives rise to one of the most amazing solution techniques for all equations that has nothing really to do with algebra per se. It's pure graphical. Let's get rid of the calculator right now. And let's fill in some blanks. All right. So to solve the equation f of x equals g of x, whatever f of x and g of x are, what do? Well, you're going to graph both f of x and g of x, and then you're going to find the intersection points of their graphs. And let me just be very clear, you're going to then use the x values. All right? Because that's ultimately what we're solving for when we solve an equation. We're solving for x or t. We're not particularly solving for y in this case. All right? This allows us to solve basically any kind of an equation that we now want, even if we have no algebraic technique whatsoever to solve it. So I'm going to clear this out, and then we're going to solve an equation the likes of which we've never solved before in this course. Bye-bye text. All right, let's do one. Exercise 2. Consider the equation x squared minus 11 equals negative 2x plus 4. We will eventually have multiple algebraic methods for solving this quadratic equation. Multiple methods. Factoring, the completing the square, all sorts of things, the quadratic formula. But for right now, we're just going to solve it graphically. All right, so remember how we're going to do this before we open up the calculator, right? We're going to have one function, let's say x squared minus 11, and another function, negative 2x plus 4. What we're going to do is we're going to ask the calculator to find their intersection points. So let's open up the calculator now. All right, let's go back into y equals, clear out the equations that are there from our last problem. In y1, let's put in x squared, remember where the squared button is, minus 11. In y2, let's put in negative 2x plus 4. Be careful, make sure that's a negative and not a subtraction sign. You just use the subtraction for the 11. It'd be easy to make that mistake. Now I've given you the window here. Sometimes when you're solving equations graphically, the hardest part is actually to find the window. So if you're not sure what the window is, always experiment. But let's go into the window and let's set x min at negative 8, x max at positive 8, y min is negative 20, y max is positive 20. Okay, make sure we've got all that set. And let's hit graph, see what it looks like. Might take a little while. Your calculator's going to be quicker than mine. All right. Now we have to ask the calculator to find the intersection points. Okay, so we're going to go to that calculate menu. Again, remember that's hitting second trace, or not, sorry, not second, yeah, second trace. You'd think I would know that after using it for the better part of 2 decades. Now here there's 2 intersection points, which is kind of cool. So we're going to ask the calculator to find them. So let's go down to intersect. First curve, just hit enter. Second curve, hit enter. Now when it says guess, we need to move the thing to whichever one we want. So I'm going to bring it over to the leftmost intersection point. And I'm going to hit enter. And it thinks a little while. And it tells me my intersection is at negative 5, 14. All right. In fact, I'm going to sketch the graph in just a little bit, but I'm going to write those down on the paper now. Negative 5, 14. We have to find the other one. So let's hit second trace to get back into the calculate menu. Go down to intersect, grab it. All right. Let's hit first curve, enter. Second curve, enter. Guess. Got to move the cursor now more towards the right one. Okay. Enter. And our second intersection point is at 3, negative 2. All right. Let me clear out the calculator really quick. All right. I graphed this beforehand, so I know what it looks like. Oh, that is not what it looks like, though. I tell you. Graph and parabolas. So that is a nice looking parabola. Something like this, right? So we had those 2 intersection points. One was at negative 5, 14. And one of them was at positive 3, negative 2. Now I'm gonna get rid of this because I really want to emphasize now, right, that there are now 2 solutions to this equation. All right, an equation that currently we don't know how to solve algebraically. But the 2 solutions are negative 5 and positive 3, the x-coordinates only. All right. Now, it's relatively easy to check. Let's check with the negative 5. Let's check with the 3, and then we'll leave the negative 5. So if I want to check the negative 3, right, then what I'm going to do is I'm going to put it into my equation and see if both sides are equal. Right? 3 squared is 9. Negative 2 times 3 is negative 6. And we get negative 2 equals negative 2. By the way, notice that that negative 2 also shows up, right? It's right there, but it's not really part of the solution. We're using the graph as a tool to find the values of x that make this expression's output equal to this expression's output. And the 2 values of x that do it are negative 5 and 3. All right? Isn't that neat? The intersection points of a graph give us the solutions to an equation. All right. I am going to clear this out. Copy down whatever you need to. All right, here it goes. Okay, let's play around with a problem where the graph is already given to us. Exercise 3. The function f of x equals 2 times the absolute value, remember those are what those bars mean, absolute value of x plus 1 minus 8 is shown on the grid below. Use it to help answer the following questions. It says find all values of x that solve the equation shown below. Circle the points on the graph that illustrate your answer. So assuming that you don't know how to solve this algebraically, right, what it's really saying is figure out where the output, right, of this graph, where the output or the y value is equal to 0. Well, that's right here and right here. So we can say 1, 2, 3, 4, 5. X equals -5 must be a solution to this equation. And 1, 2, 3. X equals 3 must be a solution. Right? Boy, that looks awfully familiar based on the last problem. Not intended. All right. Take a look at B. It says find all values of x that solve the equation shown below. Okay, so same thing, but now we want to figure out where the output is equal to -2. See if you can figure that out. What x values give us an output equal to -2? All right. Well, one way of thinking about this is saying, well, that's the same as sketching on the line y equals -2. They intersect here and here at 1, 2, 3, 4. X equals -4, and at x equals 2. Now letter C, it says find all values of x that solve the equation shown below, this one. All right, this will necessitate a bit more work on your part. Verify the values of x that you found are in fact solutions to the equation. Show the steps in your check. All right, so this one definitely takes a little bit more work, and I'm going to get rid of everything that I've kind of drawn so far so it's really clear. So now it's a little bit harder. Now we really have to think about what we did on the front side of the sheet. Well, we already have this graphed. We already have this graphed. What we need to do is we need to graph this. So we need to graph y equals x minus 1. But of course that's a line, right, whose slope is 1 and whose y-intercept is -1. So what would that look like? Kind of look like that with a slope of 1. We'd have something that kind of looks like this. I'm going to see if maybe I can use my line drawing. All right, there's that line. So what's going to solve that equation? Well, it's going to be the intersection points again, right? And they're going to occur here and here. That's going to be at 1, 2, 3, 4, 5. So x equals 5, and 1, 2, 3, x equals -3. I apparently like 5 and 3 a lot today. So let's do a little check on this. And again, let's check x equals -3. We'll save the x equals 5 as your own check. So let's try that. I'm going to put in -3. And see what happens. Now, always treat absolute value bars as if they're kind of parentheses, right? Do whatever's inside of them first. -3 minus 1 is -4. But watch out here, of course, the absolute value of -2 is +2. Right? So now we're going to have 2 times 2, which is 4, minus 8 is equal to -4. And -4 is equal to -4. Awesome. Right? So it checks out just fine. So one very nice way of solving equations is by graphing both sides of the equation and finding the intersection values. If one side of the equation is a constant, it's not so hard. In fact, you may not even have to graph that side at all. You might be able to just visually look at the graph. That's kind of part A and part B. But if both sides have variables in them, and you can graph them by either using technology or by doing whatever you need to by hand, then you can easily find those intersection points. All right, I'm going to clear all this out, and then we're going to do one last multiple choice problem. Okay, here goes the text. All right. So exercise number 4 says the functions y equals negative x squared plus 4x and y equals 4 minus x are graphed on the grid shown. Which of the following sets gives all solutions to the following equation? All right. Now notice this equation is simply what you have when this is set equal to this, right? So if I were to solve this graphically, what I'd want is I'd want this graphed and this graphed, but that's what we have. So which of those sets gives me the solution to this equation? All right, let's take a look. Well, we know we can find the solutions by coming up with the x-coordinates of the intersections. We just have to be careful, right? Because this is at 1, 3. This point is at 4, 0. Barely squeeze that in. So the key is the solution set only x-coordinates 1, 4. Okay. Don't be fooled by using the y-coordinates. No 0s and 3s. Okay. Just the x-coordinates 1 and 4. All right. Clear that out. So remember, what do? We graph the left side, we graph the right side, we find their intersection points. The x-coordinates are the solutions to the equation. Let's finish up. There are going to be many algebraic techniques that you'll learn both in this course and in future courses like Algebra 2. But probably one of, if not the most powerful equation solving techniques is graphing both sides of the equation, finding the intersection points, especially using technology, and then using the x-coordinates of intersection as the solutions to the equation. All right, so it's a great one to get in your toolbox right now. All right. Well, until next time, let me remind you that this has been another eMathInstruction Common Core Algebra 1 lesson. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.